I met Lew in 1983 when I was in Bible school, and he taught us, and then I decided I'd go up to his place and spend a couple of weeks there with him because he was a youth leader at the New Lynn Bible Chapel, and that was my introduction to youth work, and you didn't sleep at Lew's place. But it's great, so many years later, he's here with us, and it's a privilege to have him here. I know he's a very busy man. He runs beach missions, he runs outreach and church ministries in Auckland. He's around the country preaching. He's got a family. If you don't know, he came down here on Saturday and ran a seminar and went home to his daughter's 21st and was back here Sunday morning to preach. So he loves the Lord. But Lew comes from a science family. They're all into science. His wife, Angela, has a degree in plant physiology, and Lew has a degree in biochemistry. And when he graduated, he started working in a protein research lab in Massey University. But now he speaks to evidence of Christianity from a science point of view. And he's also a Christian communicator. So he goes all over the place. He spoke at Mainly Music this morning. He's speaking at Cafe tomorrow. He'll be speaking to the youth. He'll speak to rally. So we're keeping him busy. He also trains chaplains, community chaplains, so that they can go into the community and be men and women reaching out in our communities. And I'd encourage you, if you want to be a community chaplain, come and see me or talk to Robert. He's just done the training. Neville is a community chaplain, Neville Kemp. I heard him here earlier. He might be still in a meeting. But Lew and his wife does that training. And he's also a leader in the church in West Auckland. So it's a real privilege to have him here. But he's also an author. He writes these small books, and you might have seen as you come in a table of books. He has a series called Great News and for different groups. And possibly the book for tonight is What Killed Evolution. And these are available for $4 each. And as Lew has to make a living from that, well, has to pay for the printing anyway, doesn't make a living from it. There will be FPOS available. So if you want to get some books later, there'll be someone down there. So Lew, thanks for coming to Te Awamutu Bible Chapel. And thanks for leading us tonight. Thank you.
Thank you, Shane. After that introduction, I can't wait to hear what I've got to say. Hey, thanks for coming tonight. And I'm going to be talking a lot about science. And I don't know if some of you only went to school to eat your lunch, and it was somebody else's lunch, as a friend of mine said. And so maybe you didn't listen too much to your science teacher. But that's all right. I'm going to try to break it down, but I can't break it down for everybody here. And I can't cover the whole topic in 45 minutes to an hour and a half. But we'll see how we go, eh? We'll see how we go. Now, if there's a question that won't wait, you can pop it in. But I'd rather have most of the questions at the end, if that's all right. Okay. So welcome and thank you. So my topic tonight is the Bible, science and design. And I want to start by talking a little bit about science. I'll start by turning the clicker on. Get the technology working. Okay, so what is science? Well, the true meaning of the word science is knowledge. That's all the word means. And so bioscience is knowledge about the biosphere. So that's what the word means. It means knowledge, okay? But people have changed the meaning of the word science to suit their own agendas. And I want to talk to this for a moment. So if science means knowledge, and if the Bible contains true knowledge, well, then the Bible will be in harmony with science, because it is science. And so in that sense of the broader meaning of the word science, the Bible is part of that, if it's true, if it is genuine knowledge. And so are many, many other books around the world that are genuine knowledge, okay? So we shouldn't necessarily make a distinction between science and the Bible. They're not in opposition to each other. if we understand the true meaning of science. So there'll be no contradiction. In science, we talk about empirical science. And empirical science is where you can observe something and you can repeat that thing and you can test it. Okay, so you observed that this clicker accelerated towards the ground when I released it. And I was able to repeat that little experiment, and we can actually suggest what we call an hypothesis, that there is an invisible force acting on that, so that when I release it, it accelerates it towards the ground. And we can repeat it and measure the force, and for the sake of giving it a word, we could call it gravity, and so that's empirical science. Now, empirical science is fine for the here and now, but there's historical science that we can't be quite so sure about. So what happened in the distant past? What happened 1 billion years ago, or 1 million years ago, or 1,000 years ago? We can't be quite so sure. We can't call it science in the same way because it's not definite knowledge, okay? Or something that happened the other side of the universe. We don't know what influences that information in the form of light has gone through on the way here. There could be all sorts of things going on out there that we have no idea about. So we can't be so certain. We can't call it certain knowledge. And so it is in a way science, but it's very speculative. Okay? And it is very susceptible to our assumptions. Let me give you an example. If I was looking for fossils and I was in Greece, in ancient Greece, and I dug in a mountain and I found a fossil of a fish. If I was an ancient Greek, I would have probably believed in a whole bunch of deities, some of which were quite stupid and entertaining, and I might say, ha, the gods are playing a trick on us. They're having a good laugh because we know fish don't swim in mountains. Good one. But of course, if I believed in the biblical concept of God, I would say, well, this fish has been buried in mud, which has gone through a natural concreting process and hardened, and the mineralizations from the rocks has left the imprint in the blood in the rocks, and we have a fossil. Because the concept of God in the Bible is not a goofball who plays tricks on people, but one that's consistent. And so, depending on my assumptions, my conclusion may be different. And so our assumptions will affect the science where we can't be quite so sure about it. So I'm going to talk about pop science or popular science, not intending to be derogatory, but when a lot of people popularly use the word science, they may not realize it, but they're injecting an assumption into that meaning of science. And the assumption is that spiritual and eternal things cannot be part of it, okay? So pop science is either agnostic, which means it doesn't know about God, or it's atheistic, which means it doesn't believe in God at all, or doesn't allow for the existence of God in the system. So it assumes there's no ultimate design behind the cosmos and its contents, and I would argue it's a tool for atheism and agnosticism when we use science in this way. And again, I call it pop science. So when it comes to science and scientific research, it's kind of like in the origin of the universe, it's kind of like saying, all right, explain where that came from, but you're not allowed to even mention the possibility of a manufacturer, okay? So you've got to explain it all naturally. You're not allowed to say there's a designer or there's a manufacturer that brought it into existence, because and that's what we're doing when people use science in that way. They're saying you can explain things with science, but you mustn't talk about God or a creator. It's all got to be based on what can and can't happen in this time-space universe from the time when time and space came into existence. And there's no such thing as time unless there's objects, and when it will go out of existence. So there are limitations on pop science. It's narrowed to the analysis of this one cosmos, or time and space continuum that we call the universe. It presupposes that everything can be explained in terms of what can naturally happen in this world. Having said that, there is now a whole new area of astrophysics that's very speculative, that talks about other universes, multi-universes, other dimensions, things like that. Okay? And of course it's speculative because you can't go into them and come out of them and survive. And if you went into a black hole, you wouldn't survive to tell us about it. And so it's all a bit speculative, but it is actually a modern area of science because scientists know that they actually can't explain everything in this world, naturally. Even gravity, we're not totally 100% sure how it operates, and some are suggesting that it operates through another dimension. I don't know. Gravity gets me down. I know that. So it presupposes that this limited version of science that we often call science, and we put in opposition to religion, it's like faith or science. Now that's a false dichotomy, okay, because science means knowledge. It presupposes that everything can be explained in terms of natural phenomena. So my question now here is, do we have good reason for allowing for the possibility of something beyond nature to explain the universe? And I would argue we do. You see, in philosophy, there is a statement that says, you can say almost anything in philosophy and call it philosophy, but this well-known philosophical statement says no one can prove a universal negative. Now, what does that mean? Well, I explain it. No one can prove that God does not exist at all anywhere. So you could stand up and say, I believe there is no God anywhere, but you can't prove it because you can't go right throughout this universe and right throughout all the other universes that may or may not exist and check it out. Okay, so you can't prove it 100%. Okay, and in science generally, of course, we don't hardly ever use 100% certainty, particularly on things that we can't see right in front of us. So because of that case, we should certainly at least be open to the existence of an influence from outside of our universe that can have an influence in this universe. So that's a good reason, I believe, for allowing for the possibility of outside influence, as in God. Pop science cannot necessarily discern and interpret spiritual activity. Like it or not, spiritual activity does happen in this world. You know, there are such things as demonic activity. We don't see it so blatantly in New Zealand, but go to India, go to places that are loaded with occult, and this stuff happens that science can't explain. Just can't. And there's things like answers to prayer. People try to explain them away. Oh, you know, that's just a fortunate gathering of positive things for you. But those positive things seem to gather a lot more often when we pray about them. And so there's things that science cannot explain. Paranormal activity, we could call it, and miracles, we call them, we call it supernatural activity, but of course from God's perspective it's simply natural activity, because supernatural to us is natural to him. And so pop science can't explain everything by any means. They can't even explain all of the scientific things like where is the dark matter, where is the 90% of the universe that's supposed to exist of their calculations from the Big Bang Theory, which is only a theory, are true. And so there's an awful lot of question marks in pop science as well. So we have good reason to say, let's at least be open to the idea that there is an influence. The ultimate reality may well be beyond our time-space dimension and be able to have an influence here. That seems to me to be the best model, and I want to explain why. So I want to look at three challenges to the idea that science, that naturalistic science, that science without any outside influence from our universe can explain everything. And the first one is in fact the beginning of the universe, or the origin of the cosmos. And that is popularly called the Big Bang. Now there's lots of different theories around the world, but the most popular one is what we call the Big Bang Theory. And that was proposed, I think, by Edwin Hubble originally, of the famous Hubble telescope. And it's mainly understood for two reasons. One is that, that in the universe, we have something called red shift, okay? Now, red shift is when we look at light and it seems reddish, okay? Now, to explain this, and this is not a perfect illustration, but I need to, have you ever stood beside a railway track or a road where a big truck's coming along and it's blowing its horn and it goes, okay, so when it's coming towards you, it's higher, and when it goes away, it's lower. I deliberately made that noise. That wasn't the meal I had tonight. And so that's called the Doppler effect, because what's happening is the sound waves are being compressed as they come towards you. So they're more often higher frequency. And as they go away, they're being stretched because you've got to add the speed of the truck moving away. So it stretches them, okay? So stretched is a lower frequency. Now, similarly, it's believed that light coming towards us will be compressed, so it'll move towards the bluish end of the spectrum, which is the higher energy. But if it's going away, it will be stretched because you've got to add the speed to the speed of light, and so you've got a higher frequency, and so it'll look reddish, okay, lower energy and reddish. So that's one of the reasons. The other reason is that out in space is energy, and the energy is in the form of microwave radiation, and it's a bit like, what you cook when you want to cook something, you put it in the microwave. It's similar to that. And so the question is, well, where did that radiation come from? And so it is posited, the idea is presented that this is a result of the Big Bang, okay, the big explosion. So what is the Big Bang? Well, it's the idea that about 17 billion years ago, and scientists debate exactly how long ago, but around about that time, the singularity, so something tiny, maybe smaller than an atom, maybe bigger, began an explosive expansion that carries on to this day. Now, the problem with this theory, there's a number of things about it. The problem with this theory is you've got to explain what banged. So where did the singularity come from? And now, I used to make gunpowder when I was a kid. Fortunately, I never got a big bang. I didn't compact it enough. But, I put sulfur and charcoal and the other stuff together with you, in case we've got any potential terrorists. We'll leave that here. And ground them together, and I got a big fizz, right? But even I, in my limited intelligence, having come from Otaki, even I knew that you can't sit there and wait while nothing explodes. And so the problem that arises is that naturalistic idea of science cannot explain where whatever banged came from. Okay, so it's got limitations, and that's why we should be, if we're going to be intellectually honest, should be entirely open. I mean, God may have used the Big Bang. A lot of Christians believe that happened. A lot of Christian thinkers believe that that's how it happened. I think there are other models which may be better, and I'll share a couple of them. But if that's how it happened, well, something had to cause it. We know that explosions don't happen unless there is a threshold energy to start with. So where did that come from? So let's not think that naturalistic science can explain the universe, because it can't. And so the problem with this concept of limiting science to what can be explained by natural processes, that you have to believe something that I consider absurd. You might consider it's okay. And that's this, that absolutely everything came as a result of absolutely nothing, the activity of nothing, okay, for absolutely no reason. Now, there can't be any reason, because reason has to do with intelligence. So if you're insisting on a non-intelligent cause of the universe, it's absurd. So there's no reason, and nothing produced something. Now even a 7-year-old can tell me what nothing produces, what comes from nothing. The answer is simply nothing. We know all that in our time-space universe and with the laws of science as we know and understand them. Of course, in a dimension beyond, an eternal dimension beyond, the current laws of science that we live under don't necessarily apply. So you can have an existence that doesn't have an origin in the sense that we understand origins in our time-space continuum. So anyway, some people say these days, because they're getting a little bit desperate, perhaps the universe was caused by the laws of science. And when I read that, I thought, really? How could the law... It's a little bit like saying the road rules can produce a motor vehicle. And we know that that's not the case. Rules don't have an intelligence or a creativity as far as they know. They are simply a description of the parameters or restrictions that govern a system. And so in science, we believe in the first and the second and the third law of thermodynamics. And they govern this universe in which we live. But they can't create anything because they don't have intelligence. They're just systems, part of the system that governs it. There's some other models. I wonder sometimes about the scroll model. You know, Einstein told us that the universe was curved. He got a lot of stuff right, by the way. A lot about relativity and all that stuff. He was ahead of his time. He told us that the universe was curved. And I thought, when I heard that, I thought, you know, the Bible says in Isaiah, all the stars of the heavens will be dissolved and the sky rolled up like a scroll. So that, if that was the case, and God unrolled it at creation, he's going to roll it up at the end somehow. Well, that would mean, that would fit in quite nicely with the universe being curved, because a scroll is curved throughout its existence. So who knows? Maybe it wasn't the Big Bang, maybe it was the big unrolling of the scroll. And maybe those things that look like eons away are actually a lot closer to us than we realize, because we are seeing around the curve, but maybe they're right here. Who knows? Because it's outside of our reach. And then there's the plasma model. This is another interesting one. And this is proposed by Barry Setterfield and Greg Norman, a couple of mathematicians and astronomers. And they base theirs on the fact that when we have been testing the speed of light since 1824, not me personally, but and we know that time has been slowing down. Sorry, the speed of light has been decaying. If you graph it, it comes out on a decay curve. And if that being the case, it links in with this model. There's a lot of plasma energy. You know those plasma ball things? It's really weird energy. There's a lot of that out in space. And where those plasma bands cross, you get star formation. So maybe the universe has something to do with the energy called plasma. A lot of scientists don't want to go there because this allows for a young universe that the Bible seems to be talking about. So, but that's another interesting model. And some people are saying, I've forgotten who it was, Richard Dawkins suggested that maybe life was seeded on our planet from outer space. And to me, that's getting a little bit desperate. And one of the reasons that that idea is highly unlikely scientifically is because our universe, and particularly our solar system, is so finely tuned in a whole lot of scientific areas. A whole lot of its qualities are so finely tuned that some of them, if they were only 1,000th different, life on Earth wouldn't be able to exist. And it's an interesting study, and we don't have time for it today. But we call this the Anthropic Principle, that our part of the universe seems incredibly unlikely if you're going to have it happen entirely randomly, but incredibly perfectly balanced and tuned for having human life and biological life on it. Which means that the likelihood of aliens being anywhere in existence is very, 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 very unlikely at all. So maybe, even though it makes great movies, maybe we should think not in terms of aliens. And when you look at the logistics of their travel here, to deposit that life in the reality of the size of space, it doesn't seem like it's really feasible. But I'll let you study that for yourself, but just let you know that there are other ideas for life on Earth and things like that. The second, and perhaps the greatest challenge to the idea that life on Earth can all be explained by natural processes is the problem of the first living cell. And this is the one which is probably the most devastating for scientists. Charles Darwin believed in his day that living cells were fairly simple gelatinous blobs of which things seem to be made. Well, with our modern research, which has gone from strength to strength, and the massive amount of information that we now have, that's certainly not the case. So the challenge is the origin of the first living cell. Now, to help you to understand how big this problem is, I want to try to talk about some of the roadblocks to stop it happening that are in there, in the system. First thing is what we need is to make a living cell. One of the molecules that living cells are made of are called proteins. And a protein is a chain of amino acids. And that was the area that I worked in a research team in protein chemistry. So these amino acids, about 20 of them, the common ones, and they make up our proteins. And they've got to be in the right order to work. Okay, so how do we get them? The problem starts straight away is that if you made them in a lake or something with a bit of lightning and you had all the right chemicals in there, zoop, you would make, the thing about these molecules is that they rotate light, okay? And you would get what's called a racemic mixture. You get 50% that rotated light like that way, and the other 50% would be like a glove, same atoms, same forces, but a mirror image, and it rotates light another way. Now that's all fine. So if you produce these things in nature, you get 50-50. That's all fine, but the problem is that in life, we only use left-handed ones. Right-handed ones are poison. They block up the system. They make the proteins don't come into the right shape. So the question is, how do you get a system that can choose only the left-handed ones and get rid of any right-handed ones that have come through? And our cells have the capacity to do that. Okay, so that's the first problem. You're going to make a protein with 1,000 amino acids. If you make the one that fixes nitrogen in plants and their roots and things into the soil so that we can live and survive, that's got 2,000 amino acids. How are you going to get 2,000 of them only left-handed when your mixture that you're choosing from randomly has got half right and half left? Problem. So that's the first challenge. It's called optical isomerism. Okay, the next challenge is how do you get them in the right order? Now in life, that order comes from the DNA. So the DNA sends a messenger, and it's got the code. And so the cell uses the code to choose which amino acid goes there and there and there and there and there. And so they've got to be in the right order. Now this presents a massive statistical problem to the development of a cell by natural processes. And the fact that they've got to go in the right order. Skip that one. Chuck Missler says this: the simple cell turns out to be a miniaturized city of unparalleled complexity and adaptive design, including automated assembly plants and processing units featuring robot machines, protein molecules with as many as 3,000 atoms in each in three-dimensional configurations, manufacturing hundreds of thousands of specific types of products. The system design exploits artificial languages and decoding systems, memory banks for information storage, elegant control systems regulating the automated assembly of components, error correction techniques, and proofreading devices for quality control. That's a living cell. So Darwin was a wee bit off when he said they're fairly simple gelatinous blobs or something to that effect. We're talking about a miniaturized, fabulously sophisticated factory in a in a living cell. All that's got to be made by having the right proteins with the right sequences of amino acids, and that all comes from the DNA. Okay, DNA is the blueprint, the proteins are what results. So can we get a usable protein molecule from random activity, natural activity? No cells in existence, we want to make the first one because we want to evolve life. And the answer is not likely. Let me tell you how likely. Okay, getting one protein molecule in the right order, assuming there's only 10 different amino acids, because that makes the maths easier. Easier on the evolutionists too. There's about 20, so if we only consider 10, that's one followed, the chances are 1 and 1 followed by 260 zeros. That's just one molecule. one usable molecule. Again, much bigger ones out there, but we're just making it easy in the maths. Fred Hoyle, who was a famous astronomer and who mocked the Big Bang. But anyway, he said that, and he invented the title, by the way, I think, as a form of mockery, but it stuck. But he said the chance of getting one usable protein molecule is comparable with the chance of the whole solar system being filled with blind men, standing shoulder to shoulder, each with a Rubik's Cube, and if they all solved it at the moment of time, same moment of time, that's the chance of getting one protein molecule. Now, understand this. One protein molecule isn't life. And I'll tell you why soon. That protein has to be protected. And when in the research team that I was with, we used to make protein molecules in the test tube, but we had to freeze them, or we'd come back in the morning and they were just chopped up in little bits. So basically, that one protein molecule has to stay safe and complete while thousands of other different complex protein molecules and billions of copies of each are all created at the same moment of time, at the same place in the universe, and they have to somehow get themselves inside a bag, which is called a cell membrane. Now, if you try to work out the mathematics of that, you'll be in la-la land, because no scientist would ever work with those sort of statistics in his research. It would just be foolish. And so that protein chain has to be protected. And then, we've done that. So the usable sequence that comes from the DNA. So the question is, what came first, the chicken or the egg? Because we have got a factory in our cells called a ribosome that makes proteins. It's able to collect the right amino acids, and it takes information from the DNA and it puts them in order, and pop, out comes a protein. The right order, nice and supported and comfortable environment of the cell. So, but that ribosome is made up of fabulously complicated proteins. So if there were no proteins, where did the ribosome come that's full of protein from? And the ribosome's got to make the protein, so what came first, the protein or the ribosome? Well, it had to be the ribosome, which means something complex had to come first. So simple didn't move to complex. Actually, we see that in life. The DNA of human beings is actually becoming more and more corrupted. It's called genetic entropy. Every generation, there's hundreds of new mutations. You've got lots of genes, so I wouldn't worry about it in your generation, but further down the track, it's becoming more and more a problem. Enough, we'll move on. Then we have to gather sufficient quantity of big organic molecules against the second law of thermodynamics. This rule of entropy in the universe means that things don't naturally come into a highly ordered situation randomly, okay? They spread out. If I take a tin of foul-smelling gas here, and I just take the lid off, within a few seconds you'd be able to smell it, and within a minute you'd be looking at Shane wondering what happened, and then later on it would be down, because it naturally will spread out, go to a lower energy. That's the second law of thermodynamics. It's a very important rule, we can't live without it. It's not part of the curse, in spite of what people say. It's an important rule of science. But what it means is things don't naturally come together and get inside a bag in their billions in a high concentration so we can get a new living cell. So we're up against physics as well. Then the construction of cell machinery and systems that we call irreducibly complex. Now, what is an irreducibly complex system? Well, possibly you've got one at home, and that is the mouse trap. Remember, the early bird gets the worm, but the second mouse gets the cheese. And that looks like far too expensive cheese to put on a mousetrap. It's good Swiss cheese by the look of it. And Professor Michael Behe, in his book Darwin's Black Box, talks about this example. See, if you take one of those old rat traps or mouse traps, it's a single system composed of several well-matched interacting parts that contribute to the basic function, wherein the removal of any one of those parts causes the system to effectively cease functioning. What's he saying? If you've got one of those things at home and you remove just one part, it can't work. It's got to be all there. I think I've worked out there's about 11 parts. You know, that bar cannot have been successfully slamming rats, but then discovered it could do it more successfully if it was attached to wood and had a spring on it, you know. So it had to be all there. You take one component, even one of the staples, holding it together, it's not going to work. So this is what he means by a system that you can't reduce the complexity anymore and have it working. Now, nature, the living cells, the chemistry of our cells, and in fact, larger cell things are actually full of examples like this. One of the interesting ones is the single-celled bacterium that's got what looks like a tail. It's called a flagellum. And that flagellum spins. So it's basically got a tail that whips around flat out, and it drives it drives the bacterium through water or a liquid environment. That little electric motor in there, it's hardwired into the cell, and some species can whip around at 100,000 revs per minute. Now, my car can't do that, nor can yours. And some of them, they can change direction in less than a rotation. Now, that was got to be the most amazing motor in the universe, and it's smaller than a living cell. But here's my point. It's got to be totally complete, or it won't work. Can't develop from anything more simple. And we'll look at a few more of those. So here it is. It's hardwired into the cell. It's got various rings. It's got a lot of interesting engineering that's very much like electronic engineering and motors that we use today. These are protein masses making up the cogs. It's not an actual photograph because it would be more transparent, but that's what they look like. All got to be there, else it's not going to work. Okay, so the first challenge was the development of the cosmos itself. The second challenge was the development of the first living cell. And you'll be aware that evolutionary or naturalistic science's idea of evolution teaches that from one living cell, everything on Earth came, or one lot of living cells that developed. So we're all in a great big family tree. You and I are all at the tips and nodes of the branches. But back at the root was first living cells. Became multi-celled creatures and more multi-celled creatures. Can that happen? Well, a bacterium might have 1,000 pages on its information in its DNA. But we have got more like 500,000 pages on our DNA. Probably more now, for a reason that I'll explain in a little while. So, is it possible that multi-celled creatures came from single-celled creatures? The problem is the information molecule called the DNA. You've got 46 strings of DNA if you're healthy, okay, and 26 pairs, and those are called your chromosomes because they colour up kind of, stain, but they're information molecules. Creatures are like computers. If you want something new, you need the information on your DNA to get it. Okay? If you want to see something on the screen of your computer, you've got to have the software. So the DNA is the software, what you look like, and to some degree how you behave. Not totally how you behave, but to some degree, that's on your DNA, that's on your software. Okay? So it manifests itself in what we look like, and in our structure, and to some degree our behavior. Big chunks of information don't come from small changes. More than new computer programs come from mistakes on your hard drive. So scientists have traditionally believed that point mutations, little changes of information, I won't call them mistakes because that conveys a bias, but changes of information add up to make big changes of information and give us whole lots of new information so we can get something we never had. A living cell doesn't have a heart, so it doesn't need information to make a heart. It doesn't have it. It doesn't have a backbone, so it doesn't need information to make bones. It doesn't have a brain, so it doesn't need that information. But we do. Okay, so over zillions of years, these little mutations or changes added up to make big changes, and those big changes gave us an advantage over our competitors, so they got kept, and that's how life evolved. That's called the Neo-Darwinian interpretation of evolution, or something like that. Dr. Lee Spetner, who was an Israeli biophysicist, he said all point mutations that have been studied on the molecular level turn out to reduce the genetic information, and they don't increase it. Now, that's a problem, because evolution, we need to increase the information. We can reduce it by natural selection, where we breed out information we don't want. But the problem is, how do we increase it? Biology doesn't really allow that to happen, and that's the central heart of evolution. Okay, we can make a new species, but that species has got less information, less richness of information than what it came from, because we separate it from the rest of the gene pool. When I was at university, which was a long time ago, we used to talk about junk DNA. And scientists believe that about 90% of the DNA was junk. In other words, it was kind of useless leftovers from evolution. And it was meaningless because it kind of its meaning mutates out and gets changed. So that's what it was, so we were told. But things have changed. So we had the junk, and you had a coding area for coding for proteins and another coding area. But now junk virtually doesn't exist from a scientific perspective. A lot of your DNA, by the way, is used when you're formed in your mum, and it switches off. She joins the Labour Party and you come out, and it's not needed anymore in your life, but it's certainly needed to be there because you can't form in the womb if you don't have it. So and there's other stuff on the DNA like signaling abilities. It's incredibly complex. The other thing is that we've discovered that something called a frame shift means that if we're reading the DNA here, we will produce a protein. We'll send off the information to the ribosome. We'll produce protein A. But if we start reading here, we'll get protein B. And yet all of this, so this information is shared by protein A and protein B. This brings a whole new dimension into DNA. It means it's a multi-level code. You can't really evolve a multi-level code, because when you mess with one level, it affects another level. And the whole system can turn to custard, or chaos, you know. So, and we've also discovered that some of our proteins, part of the information is on one chromosome and another part's on another chromosome. Well, how does that work then? It just means that's way more sophisticated information system than we even dreamed, 40-odd years ago when I was involved. So DNA is a multi-level code, and that is a major problem. How could that have evolved? This fellow here, Anthony Flew, was probably one of the greatest atheists of the 20th century. Highly intelligent man, and a great debater against Christians and people from other religions. But he made a fatal mistake. He determined that he would follow the data where it led. In other words, he determined that he would act honestly with the information that came up in science. And the final straw for Anthony Flew was DNA. Our modern research and understanding of DNA was the last straw for him, and I don't think he became a Christian, but he certainly became a man who believed in a creator. And he died now, but it was a big shock to the atheistic community when one of their greatest heroes jumped ship. But he jumped ship because he could not explain the data that's there now through naturalistic processes. Okay, old Anthony. And Sir Fred Hoyle made the illustration, which is well known, a bit simplistic but well known. The chance that higher life forms might have emerged by evolution is comparable with the chance that a tornado sweeping through a junkyard might assemble a Boeing 747 from the materials therein. Now, I was speaking at Auckland University Atheist Club once. It was a bit scary, to be honest. I mean, they like to chew you up, spit you out. But we went on and on. It was good fun. But I asked them, I said, look, who believes that a tornado going through a rubbish tip could produce a Boeing 747? And one fella put his hand up. He seemed to think he did. And I don't normally get amazing insights, but I felt a little bit helped at that moment, because I said, but sir, would you be willing to fly in it? See, it's all very well to have a nice theory that even though it's incredibly unlikely, it's just possible, okay? But we don't work on those things in science, those sorts of probabilities in sensible science. And the other thing is that his eternal safety depended on him being willing to be honest with the evidence. So Michael Behe pointed out, he said the weakness or the impotence of Darwinian theory in accounting for the molecular basis of life. Now, he was a bit of an evolutionist, really. He didn't exactly agree with me on everything, and I'm not that clever. But he said the impotence is evident not only from the analysis in his book, which is called Darwin's Black Box, but also from the complete absence in the professional scientific literature of any detailed models by which complex biochemical systems could have been produced. In other words, it's not only not there, the scientists, they publish their stuff. I've got my name on, a couple of science papers. My wife's got a PhD, so she's sort of done more different areas. I borrow her PhD from time to time, but not really. But it's just not out there in the literature about how this actually could have happened. It's kind of like, huh? And we see it in the larger area of life as well. Take, for example, a butterfly. Now, that is an example of irreducible complexity. A monarch butterfly, these things just blow me away. You get a caterpillar to a chrysalis. How do they do that? Well, they guts themselves full for as long as they can. And after several weeks of eating, they wander off looking for somewhere to do their fifth and final skin change into a chrysalis. They find a suitable place that will protect them. They spin a button of silk with their mouth parts. They position their back legs on this, hold tight. They drop their head into a J shape. In less than 24 hours, the skin splits and falls to reveal a green, shiny skin, which wriggles into a chrysalis shape. You've probably seen all this. From holding onto the button with two legs, they are now holding on one point. About 10 days to 2 weeks later, the chrysalis splits and the butterfly emerges. It's got little pumps that it pumps up its wings. Basically, it turns to soup inside that thing, and then it turns to a butterfly. Now, think of the fabulous quantity of information on the DNA, because that process has to work perfectly every time. One little mistake, one little bit not there, no butterfly. And nature has lots of those systems, and those convince us that this has been produced in its complex form. Things can lose complexity and mutate away, but this has been complete. This appears, at least, I think, to a reasonable mind, to have been created complete and in working order. For a caterpillar to successfully change into a butterfly, it needs to do many things right the first time. The other problem that Darwin struggled with was the eye. Not that he had bad eyes. He said to his friend Asa Gray, "The eye to this day gives me a cold shudder. To think that the eye evolved by natural selection seems, I freely confess, absurd in the highest degree." Now, you don't read that in your normal high school textbooks, but that's how he felt. He had his moments, I don't think he kind of recanted. That's a popular myth in my understanding. But he had his moments, but he was actually a very meticulous, good scientist in lots of ways, a very clever naturalist. So he had his moments. Of course, Richard Dawkins, who is perhaps the high apostle of evolution these days, or its greatest evangelist, he does make philosophers, even atheistic ones, cringe at times, I think. But he's big on evolution. And he can't handle that, of course. So this is what he says, and he's trying to explain how we can get a membrane in our eyes that will pick up photons of light, okay? So, B, he says this: now that the black box of vision has been opened, it is no longer enough for an evolutionary explanation of that power to consider only the anatomical structures of whole eyes, as Darwin did in the 19th century and as popularizers of evolution continue to do. Each of the anatomical steps and structures that Darwin thought were so simple actually involves staggeringly complicated biochemical processes that cannot be papered over by rhetoric. Okay, so the explanation of the eye has got to be pretty incredible because it's such an incredible thing. So Richard Dawkins comes swinging in and says, look, in his book, Climbing Mount Improbable, he acknowledges that it is improbable, that's what the book's about. But he says, on how natural selection could produce the molecular machinery of a light-sensitive cell, he says, I could count 91 layers of membrane in this picture. Now, the picture would be of the membrane that catches photons so that we can see light. He says the exact number is not critical. It is actually. But anyway, the exact number is not critical. The point is that 91 membranes are more effective in stopping photons than 90. 90 are more effective than 89, and so on, back to one membrane, which is more effective than 0. This is the kind of thing I mean when I say there is a smooth gradient up Mount Improbable. So he's saying here, no light-sensitive membranes, 91 light-sensitive membranes, nice smooth gradient that evolutionary science over a long period of time could explain. But what is the reality? The reality is there might be a smooth gradient between one light-sensitive membrane and 91, because you can get more of the same reasonably easy in biology. But the difference between no light-sensitive membranes and one light-sensitive membrane is a staggeringly complicated process that has to be explained by brand new proteins that never existed before. Okay? To capture light, transfer information to the central nervous system so that the creature can gain an advantage. So he's not being honest with the evidence. Finally, how do we get all of those things into a cell membrane against the second law of thermodynamics? And as I pointed out, this slide's actually out of place, but our cell skins are very complex. They have to be. And it goes against the second law of thermodynamics. To a person who does not feel obliged, says Behe, to restrict his search to unintelligent causes. That's a person who's committed to be an atheist, no matter the evidence, okay? So unless you're that person and you restrict your search and only consider unintelligent causes, the straightforward conclusion is that many biochemical systems were designed. They were designed not by the laws of nature, not by chance and necessity, rather they were planned. He says life on Earth at its most fundamental level and its most critical components is the product of intelligent activity. So I think true science ought to be open enough to allow for the influence of intelligent activity from beyond the cosmos and the biosphere, from what we call in Christian circles eternity, perhaps another dimension of some sort, or the ultimate dimension. We should be cynical about limiting presuppositions that can serve an atheist agenda and the conclusions they produce. All right, now having said that, the three challenges I've tried to look at is the development of the cosmos. Secondly, and by the way, the Big Bang Theory, whether it's true or not, those things like microwave radiation and redshift can be explained by other things in the universe. When light interacts with other light, it can lose energy. The microwave background radiation could be explained as a result of God's creation, even if it was different to what a lot of scientists think. So there are other explanations. Those aren't the only explanations. So I just want to finish really because to give you time for questions. The creation of the universe, the miracles of God in the Bible, and the resurrection of Jesus are not possible in pop science. If there can't be anything outside this time-space universe, you can't explain creation for a start, but you can't explain the resurrection of Christ either. You can't explain the miracles of Jesus. You can try, say heaps of people hallucinated and all saw the same amazing dream at the same time, but it doesn't actually really work when you look at the evidence. Okay? So, but if we've got an unrestricted understanding of science, in other words, we're open enough to say, look, we'll explain what we can in terms of natural processes, because natural processes have been set up and governed by the laws of science. But we will acknowledge that there are certain things which we can only really understand by understanding that there is an intelligence beyond our time-space universe that has an influence in it. Well, then this first verse of the Bible makes sense. In the beginning, God. And that's how the Bible starts in verse 1. So is the Bible account of the origin of the universe a reasonable and most compelling model? Well, I think it's compelling. It's up to you to decide. I think it's most reasonable. It's up to you to decide. Remember, the Bible isn't a science textbook as we would have in our education system today. That was not its intention. Its intention was to convey things to its audience first and foremost. So we shouldn't judge it on the same basis we would judge, my chemistry textbook or my physics textbook that I think I still have from many moons ago. So Genesis is a summary of the origins, and is Genesis 1:1, and is in contrast to other origin explanations in the ancient world and their resulting worldviews. In the beginning, God created the heavens and the earth. And I don't know if you know about the Lew Meyer paraphrase Bible, but I've paraphrased this verse anyway. It's a start. Our time-space dimension came into existence when the ultimate reality, God, brought into existence everything up and out there and everything down here. That's what that's saying to me. Creation, how did it work? The Bible says God spoke and things came into being. So what we do is, when I speak, I take a concept from my mind and it goes through my mouth, through the ear, into your ear, to your brain. So it's about communicating a concept. So I take this to mean that God created by communicating the pattern of his mind. And the creation was all in his mind before it ever came into existence. So he took the complexity and the pattern of his mind and in a way that's natural to him but supernatural to us, communicated it onto a matrix of atoms, molecules, time, and creation was made in complete working order. And if God is who the Bible claims him to be, you don't have to say he had to use evolution, because it seems to me that everything, because of this complexity problem, the monarch butterfly problem, everything had to be complete and in working order quickly. So you can call it a quantum decline if you like. We talk about a quantum leap, a quantum decline, where God brought it down to our level in terms of into our universe, in terms of atoms, molecules, and time, which is a feature of a created universe. So, the mind of God. Creation is a communication of a plan by God. The creation model, God planted a garden for Adam and Eve to live in. The garden was every kind of tree that was beautiful to look at and good for food. Okay, mankind was originally designed to be vegetarian. I became a vegetarian once. It was the worst 6 hours of my life. But we were designed that way. But of course, our genes have become depleted, and also, I believe, as a result of a worldwide flood, that the nutrients on the earth are nowhere near what they were before that flooding. And so we're allowed to eat meat and allow those things for us. So basically, Genesis 1:1 was saying to atheists, it refutes atheism, no God, because the universe was created by God. It refutes pantheism, because God is not part of what he made. He's transcendent to it or independent of it. Refutes the idea there are many gods, because one God created all things. Refutes the idea that stuff is the ultimate reality, because there was a time when stuff didn't exist. Or it doesn't quite make sense, because time and stuff exist together, but time and matter hasn't always been there, apparently. was a bit of a shock to scientists when that was sort of discovered by Robert Jastrow. It refutes humanism, or commented on by him, because humans are not the ultimate reality. God's the ultimate reality. He's the one that we look to ultimately meet our ultimate needs. And evolutionism is refuted because God created all things. So it was to explain the biblical worldview, not all the technicalities of science. They didn't need them in those days. So if we acknowledge that it's reasonable that for the existence of an ultimate reality, God with intelligence, that's God, then the creation of the universe and life is quite feasible. The welding of God to a human being in the person of Jesus is no problem. Okay, the miracles of the Bible by God's design, his power and timing, the miracles some of the prophets did, the miracles of Jesus, they're quite easily done because you've got the involvement of an alternative dimension called eternity in time and space. And the resurrection of Jesus is a piece of cake. If you can create a universe, a resurrection's not hard. And so the beliefs in the Bible are dependent on us having an accurate belief system and that it works. And of course, the resurrection of Jesus is the crowning evidence of the Bible, because that is the proof that Jesus is the God-man, the Son of God, that his sacrifice on our behalf was accepted by our Creator, that it was acceptable, and that we are able to have life beyond this life, as he does. And that's where the Christian finds hope. If the resurrection of Jesus is not true, then Christianity is a fraud. It's not true. Okay? I'll go and try to make money, something like that. The corollary is this, okay? That what comes from this, from my perspective, is like this. Our mind is being designed by a greater mind. You can't design something greater than yourself, okay? And so God's mind must be greater because he designed my mind and your mind. Our personality and communication ability are complex. They must have been designed by one who can communicate at a higher level, a greater level, so he can speak to us. That's just logic, makes sense. We have a design plan. We've been designed. And this is, I think, one of the reasons why a lot of people, in spite of the evidence, or in spite of what science most reasonably seems to be saying, don't want to accept it. Because they suspect, and correctly so, that they haven't lived up to their design plan. And the thing about design plans is that you tend to be accountable to your designer. If you're a designer and something doesn't work, well, you either fix it or biff it, don't you? And people don't want to be fixed. We want the universe to run how we want. Thank you very much. We'd rather be God and call the shots. We might call him in when we need him occasionally, but in the end, we want to be an authority in our own lives. And that's the human condition. But our Creator has acted to bring reconciliation through what Jesus did on the cross. And to come into a relationship with the Creator is to become fully human as we're intended to be. I believe mankind is body, soul, and spirit. Your bodies look fine. Mine's starting to pack up a bit. Your soul, your mind, emotions, and will seem to be working well. Some of you got my jokes. You're intelligent. What about your spirit? What about that part of us which is designed to connect with God? And I want to suggest to you that if you agree that it's reasonable, at least reasonable, that there is an ultimate being that exists that we call God, then you pursue, you look into that, and you ask that Creator to lead you and guide you. But you need to have a willingness to come into line for the design plan, if you're going to be honest with the evidence. So let me leave you that little challenge. Now, I've gone on probably 10 minutes, more than I said I would. Sorry about that. Well, I'm not really, but you know, sort of am. But, and I can't guarantee to answer your questions, but I've fielded a few questions on this before, so I'd be very happy to try to explain myself. And if you have a question, so don't be shy. There's a microphone over there, so if you want to put your hand up, then the microphone will come to you by human means. And we don't want a raging debate. We want to keep it friendly tonight. We can have a debate later on if you want outside. Put the gloves, take the gloves off and put them on. Sir. Not very well. No, it's not working yet. Oh, that's better.
Yeah, okay. I'm a simplistic sort of a guy. I've been a farmer all my life and been very interested in breeding animals, using genetics to improve and change them. Mm-hmm. And every animal is equipped with certain attachments that cause them to breed and reproduce. What happens to these half things that are evolving? How do they reproduce? I saw a program the other day with monkeys that were little monkeys, chimpanzees that were rescued. The parents had been killed, and these little blokes were running around the house, and they didn't have nappies on, and they were fully equipped to be able to breed.
Okay,
it was quite obvious.
Yeah.
And they didn't have little bumps. They didn't have grown ones. They were fully.
They were. What you're saying, they was completely able to
reproduce.
Yeah. Okay. Now we need to understand that in evolution, some people get this wrong, and they say we came from monkeys. Okay. So they assume that sort of monkeys must have kind of we evolved from monkeys. So there was monkeys, and then there was us. The proper evolutionary position, if you believe it, is that the monkeys and us had a common ancestor. Okay, and there's and then there's a missing link. I think it could be him actually, but no. And but the idea is that it's like a big tree. So here's us, here's Neanderthals, which are quite close. I believe Neanderthals were actually ordinary people. They used to bury their dead and do religious things. But and then there's other ape-like creatures, and but there was a creature that gave rise to them and us. And Christians who believe that, because there are Christians who believe in evolution, they believe that at some stage a primate got to a certain level, evolved level in intelligence, and that the Creator endowed them with the spirituality part of their being, with the soul. And humanity developed along that line. So that's the theistic evolutionist position. I don't agree with it personally. But I'm not going to beat people up because they believe that. I mean, So the idea is common ancestry. So that creature would have had gonads, and the creatures before would have had gonads, and we have gonads. And so it's not a question of the reproductive apparatus growing and developing where it didn't exist. It's existed all along, according to evolutionary theory. Yeah, we can lose them by evolution, but they were always there. The mind boggles, doesn't it? No, thank you. Okay. Any other questions? You probably want to go home. Yes, ma'am.
I'm interested in the fact that at the beginning in the Bible, people lived for so much longer, but your explanation of what happens to our DNA explains that.
Yeah, because and some scientists, I understand, would say when you really look at the way we are made and the protective mechanisms that are in there, and how our mind has got plasticity and it can rewire itself and things can heal themselves. It does appear, and a lot of people say, look, it looks like we were designed to live for a lot longer. And my personal feeling is, and certainly there is certain amount of evidence in archaeology that people lived a lot longer. More recently, people lived a lot shorter. If you go to the UK, a few hundred years ago, that 50 would have been an old man. And so we've lived even shorter, but that's partly because of choosing to live in England and things like that, I think summer next year is going to be on a Tuesday in England, and the vitamin D. But if you project that back, it does appear that humans lived a lot longer. And one of the archaeological things they found was the Sumerian king list, which interestingly apparently recorded the royal families of certain areas in the Middle East and in Europe, because they're all connected, Europe, Africa, and Asia and stuff, even before the flood, and extraordinarily long lifespans before the flood. Now, you could explain, maybe years were quicker and things changed in the cosmos, but I just think we were designed to live about 1,000 years. And then, now, theologically, I think live 1,000 years and then be translated into heaven if we hadn't sinned, you know. No need to die if you haven't sinned. Spend your time here and then go to heaven. But of course, because of mutations and all of the diseases, genetic diseases and other diseases and the poor nutrition, human beings live a lot less. But actually now with better nutrition and health shops and more education, we're actually moving up again on average. And I've got a mate who reckons that, he said, women live longer than men, but that's because they don't have wives, he reckons. And, but apparently, actually that, but apparently, I might not live much longer if I'm not careful. And so we're actually increasing the age. And it does seem that the mankind can live older, but not much older than 120. And there's very few people, if any, that are over 120. But we could theoretically live that long. And it's interesting, the Bible says that God limited the human age to 120. Moses observed that most people live around 70 on average, but that wasn't a dictum by God. That was just an observation about what happens. So I understand we are living. I resent that. Wouldn't it be wonderful if you could live for 800 or 900 years? You could spend a whole 100 years learning. It'd be awesome. Anyway, imagine how many children you could have, ladies. Have we got time for a couple more, Shane? Yes, mate? Yep, you.
So if chemistry can result in the creation of different things, what does that mean as God is a creator themselves? And
sorry, buddy. Can you just say that one more time? I just need to hear it clearly. Just hold the mic a little bit less close. That's good.
So if chemistry can result in the creation of things, did God intend on those possibilities being possible?
Yeah. Chemistry itself can't produce anything, okay? God had to use the chemicals to put it together. So we're made of chemistry. We're chemical. We're big bags of chemicals wandering around, but the information had to be put in there to make it all work in the right order. So chemistry itself doesn't explain life. I mean, from an evolutionary point of view, it has to, sooner or later. And they believe in a very gradual progression. But from my understanding, God used chemicals to put us together. So he put chemistry plus information. And he ended up... And you do the same when you make something. You do a picture, you use chemistry, you use art, paint, things like that. You write a book, you're a writer, aren't you? Are you a writer? Was it you? No. Okay, maybe one day. And you put these things together, but you put intelligent information into it. And that's what makes it come together and be sensible. Else it's just random. And random doesn't make anything. Random can make a few things by pure chance, but nothing really complex. Okay, got time for one or two more. Maybe one more. Sir, you're going to be kind to me?
Should science shape your worldview, or does your worldview change your science view?
The question is, should science shape your worldview, or should your worldview shape your science view of science? And the answer is science, in its true meaning, which means knowledge, should shape your worldview. If you will let your worldview shape your understanding of science, then you could be anything. You might have a really bizarre, weird worldview, like we are the result of the great green frog being that lives just the other side of the moon that put everything into existence. And so then your understanding of science will be probably quite different. And so really, your science, if it's true science and not science that shaves God off so you end up with the result you want, if it's true science, that should shape your that should shape your worldview and your understanding of life and the universe. That's my take on it. Good question. Never been asked that one before. Where did Cain get his wife from? I'm not able. Over to you, Shane. Thank you.
I think we better finish there. Hey, thank you, Lew, for coming in and sharing all that with us, and it's great to have you. Lew will be here for the rest of the week, except Friday and Saturday, but he's here in the chapel if you would like to come and talk to him, and just give us a ring, because he is going out speaking at different places, and he'll be here on Sundays doing an equip class at 9 o'clock, and also speaking in the service at 10 o'clock. So you're very welcome to join us. I'm going to ask our lead pastor, Brad, to close in prayer for us tonight, and we'll get a cup of tea up and running while he's doing that. So you've got 5 minutes to pray. Okay. Thank you very much for coming.
Yeah, and thanks, Lew. Again, it's been great to have you here. Let's pray. Our Father, we've been just witnessing this evening the incredible intricacy of your creation. You are an incredible creator. And we thank you that we've been able to spend this time just to have our minds just opened a little bit to the glory that you have been able to imprint, not in just the massive things that we see around us, like the mountains and the oceans, but also your incredible glory in the minutiae, in DNA, and in proteins, and in the things that we can't even see until we get under a microscope. And so we just praise you for who you are, and for your incredible wisdom, your incredible power in creation. Lord, I pray that you would just continue to work in our hearts, particularly if we have been struggling with these things. For any here who have been thinking these things over, Lord, I pray that you would just help them to continue to wrestle with the evidence and wrestle with these things that we've been talking about tonight. So we just give you all the thanks and all the glory and all the praise, and we ask that you would just bless us as we head from here and enjoy a bit of time together as well, and bless the rest of the week that Lew has with us, and we just thank you for bringing him to us this week. We pray all these things in Jesus' wonderful and saving name. Amen. Thanks. Enjoy the rest of your evening.